Modern computational physics operates on a widely accepted premise. To simulate reality, you must fit your equations to experimental data. Relying on empirically tuned floating-point variables creates a structural vulnerability. When parameters are hand-tuned to match observations, models can become over-parameterized, creating a mathematical smokescreen that masks structural errors. The Marithmetics pipeline presents a deterministic alternative, integer-to-physics emergence. This framework derives physical parameters directly from discrete residue phase topology, a pure number theory mapping cyclical patterns in integer remainders. By relying solely on mathematical structures, the pipeline bypasses external data entirely. True audit-grade computational physics requires built-in falsification. A rigorous system must include automated negative controls, mathematical tripwires designed to actively fail if the underlying logic is flawed. Removing empirical tuning yields a simulation that functions as a rigorous mathematical proof of physical behavior. To examine this concept, we track a specific execution log, Demo 67, the Navier Stokes master flagship. The target here is a 3D pseudospectral Taylor-Green vortex. The Taylor-Green vortex is a mathematical benchmark used to test fluid dynamic solvers by observing the decay of an idealized flow into turbulence. This specific demonstration is engineered for the industrial tier, processing at an n equals 256 scale. It accomplishes this without generating a single random number. The output is entirely deterministic, yielding an execution log that acts as a referee-ready industrial certificate. We are going to track the exact execution sequence of this log through its 5 deterministic stages. We are testing whether pure integers can compile into verifiable, incompressible fluid dynamics without the need for traditional empirical fitting. Stage 1 of the log executes deterministic triple selection. The system locks onto 3 specific primary integers, 137, 107, and 103. No random numbers or empirical guesses are injected. This triple serves as a fixed foundational invariant. In stage 2, pure integers translate into precise physical budgets for the simulation. The primary triple algorithmically generates grid size n equals 128, truth budget 63, and time delta 0.0122. Look at the kinematic viscosity, returning 0.00098039156862745. This fluid resistance is strictly derived from the initial integers. The discrete temporal boundaries, a total time of 0.6 executed across 49 steps, are bound by the same first principles, locking the physical grid in place. Traditional physics relies on floating-point empiricism for these variables. In this pipeline, every physical parameter is a direct numerical consequence of the starting triple. Before a single frame of physics is calculated, the geometric and temporal boundaries of reality have already been fixed by pure number theory. Before executing the fluid simulation, Stage 3 audits the mathematical operators for admissibility. This 1D line graph tracks the Fejér kernel, our designated lawful operator. The Fejér kernel is an averaging sequence that prevents non-physical oscillations in reconstructed wave signals. As the graph shows, it is mathematically verified to be entirely non-negative in real space. A true audit requires negative controls. The system intentionally constructs illegal operators, starting with a sharp cutoff kernel. This kernel is structurally flawed, possessing non-admissible negative lobes dipping below the zero axis. The signed control kernel exhibits an even more extreme negative minimum. These negative lobes correspond to a surge in high-frequency weight energy fraction. High-frequency weight measures the proportion of a system's total energy trapped in erratic, microscopic structural scales. The signed illegal operator holds a mathematically unstable high-frequency fraction of 0.891. These illegal operators are mathematically rigged to fail. They act as automated traps, proving the system can successfully identify and reject non-physical behavior. Stage 4 launches the 3D incompressible Navier Stokes execution, testing all 3 audited operators simultaneously. The log hits gate none, the incompressibility check. Divergence L2 confirms the fluid obeys mass conservation. Both lawful and illegal variants pass. Gate 2 evaluates the certificate score against baseline truth. The lawful operator scores an accurate 7.66, while illegal controls fail with 28.43. The physical manifestation of the lawful operator's success is clear. Its calculated energy states track exceptionally close to the established truth baseline. Meanwhile, the illegal controls disintegrate. The negative mathematical lobes identified in the Stage 3 audit predictably manifest as physical errors. The sharp cutoff and signed kernels inject massive high-frequency noise, causing severe deviation and entropy. Entropy quantifies the intensity of rotational energy within a fluid. The final entropy for the truth baseline was 0.003. By the end of the simulation, the illegal operators wildly inflated that rotation to 0.387. The log hits gate 3. The system automatically detects this high-frequency wage injection, successfully trapping the illegal behavior. The system's failure here validates the mathematical boundaries established during Stage 2. A simulation that cannot actively prove illegal physics to be false cannot be trusted to prove lawful physics to be true. The log introduces counterfactual teeth in Stage 5. A model that succeeds under all input conditions is inherently suspicious, likely hiding overparameterization. This dual-axis chart demonstrates the system intentionally breaking its rules. The derived simulation budget K is deterministically reduced to 10. Instantly, the certificate score error spikes to 35.80, crossing a strict failure threshold. The counterfactual alteration forces the score to appropriately degrade. The results are locked. 4 out of 4 counterfactual tests degrade exactly as mathematically predicted. This structural degradation proves the simulation accuracy is inextricably bound to the initial pure integers derived back in Stage 1. Pulling back, we can view the sequential architecture of the Demo 67 log in its entirety. The system starts with pure modular arithmetic, derives its geometric constants, audits its mathematical kernels, filters illegal controls through falsification gates, and survives counterfactual degradation. The pipeline terminates with a SHA-256 cryptographic hash. Because this pipeline is strictly deterministic and utilizes zero empirical tuning, executing it again will yield this exact cryptographic signature. The terminal delivers the final verdict. Pass Demo 67 verified. Marithmetics guarantees an industrial certificate of validity, a standard of mathematical proof that traditional, tuned empirical models can never achieve. Demo 67 proves that the future of computational physics modeling requires abandoning tuned empiricism in favor of deterministic, automated integer-to-physics emergence.